start with, other forms of plethysmography have been there for years, but and they were used to measure changes in arteries, but none was able to measure accurately and properly changes in the small vessels of the finger. Well, measuring the pulse at the finger, right, which is very tricky, is not enough, because, as I said, this has been available for years, and this will provide you a signal that is very prone to mechanical and physiological artifacts, to physiological confounding effects. And if you don't care for that, you end up with the very wrong signal. To start with, one that not very many know is a very nifty reflex. It's called veno-arterial reflex, that is quite prevalent when you're measuring the pulse from the finger, and it has to do with venous blood pooling. So if you allow for venous blood pooling at the tip of the finger, it may generate a reflex, the veno-arterial reflex. So it means that by applying your measurement, if you're causing venous pooling, you're generating this reflex, they're changing your measurement. If you're doing a measurement from here, can you see my finger?
Yeah.
And in order to attach your sensor, you're either putting a pressure here, or wrapping something around here, or something like that here, right? You block the venous return, and then you generate the blood pooling at the venous side here. This is a very small signal, very prone to mechanical artifacts. So you need to care for that. And then you want a signal, when a signal is very small, you really need to be very careful with the signal to noise ratio. So you need to somehow improve the dynamic range of the signal. So this is a fourth problem. So we do it by applying in a very sophisticated way, or the probe is applying, a uniform pressure field around the finger. Now, this uniform pressure field is uniform, it's stable, it's subdiastolic, it's a very certain pressure, regardless of the size of the finger. The way the probe applied is independent of the size of the finger. Now, once the probe is on the finger, any blood that goes up into the finger will be pushed back by the pressure, by the uniform pressure field, and there's no chance for blood pooling at the finger. Now, by applying this pressure externally to these arteries, you're actually reducing what we call the transmural pressure inside the arteries. The transmural pressure is the pressure between the inner side of the artery and the outer side of it. By reducing it, you're pushing the working point to a much better and favorite working point, where you get a much better compliance and a much bigger dynamic range of changes of this volume change, which is the signal that you are measuring. Increasing the dynamic range means increasing the resolution of the signal and very much improving the signal to noise ratio. You're ending up with more stable or protected from noise signal and of a much higher fidelity.
Thank you very much.
I enjoyed it too. Thank you.